Okay, here we've got a question on centre of mass by integration. It's June 2011, question 2 on edX LM3. Take a moment, make sure you're clear about what the question is asking, and resume playing when you're ready. Right, here's the question again without all the wording. It's got the important points on. You've got an area from x equals 0 to x equals 3 rotated about the x-axis. So we know the centre of mass is going to be on the x-axis somewhere by the symmetry, and we'll call it a distance x bar from the y-axis. And the standard equation for finding centre of mass of a volume of revolution about the x-axis is total mass times x bar is the integral of pi y squared x dx. The right hand side integral represents effectively the sum of an infinite number of thin disks, the sum of their masses, the pi y squared delta x, times the distances from the y-axis. So effectively that line there, that top line, represents moments about the y-axis. Check in your textbook if you're not quite clear where that comes from. So let's work out the mass first of all. The mass is equal to the volume, which is pi the integral of y squared dx. And in this case that becomes pi the integral from 0 to 3 of 9 minus x squared squared dx. Now the rest of this is pure maths, but let's just carry on with it. It's pi times the integral of 81 minus 18x squared plus x to the fourth dx. Pi then times 6x cubed plus x to the fifth over 5. Right, and that's between the limits 0 and 3, and that should have said 0 to 3. Right, if you evaluate this integral, it comes to 648 pi over 5. And that gives us the mass. So we've got the term we need for the left-hand side of the top equation. Let's carry on now then. Next page. We've got m equals 648 pi over 5. So now, m times x bar is equal to, let's put that integral in then, from the integral from 0 to 3. There's a pi in there that we can take out the front. Pi times the integral of y squared x dx. So it's going to be 9 minus x squared squared x dx. Now, this is where you need to just switch on your core maths hat. Can you integrate that easily without having to multiply it all out? Okay. I'm likely to pause the video and check that it comes to minus a half of 9 minus x squared cubed over 3 between the limits 0 and 3. Because it's a recognition type integral, and it's minus a half the integral of u squared du. Okay, when you put the values in there, you get minus a half, minus a sixth, if I take the 3 out as well, of 0 is the top limit, minus 9 cubed is the bottom limit. Right, let's put the values in there. We know m is 648 pi over 5, so 648 pi over 5 times x bar is equal to, now minus 9 cubed divided by minus 6 comes to 243 over 2. So we're there now. I've lost a pi. In fact, I've lost a pi in both places. I thought I'd cancel it out. So that's pi over 2 there. That's pi over 6 there. And there's a pi there. Sorry about that. Now the pi's cancel out. And we've got, when we turn that upside down, we've got x bar comes to check that it comes to this. X bar equals 15 over 16. Cancel out the pi and multiply by 5, divide by 648. You get x bar equals 15 over 16. And that's the answer, the final answer for 9 marks. So the mark allocation there for those 9 marks went as follows. First of all, for finding the mass, there was 3 marks. There was an M1 for the expression for the volume, the pi y squared dx there. An M1 for correctly setting up the integral, and then an A1 for correctly integrating it. So an M1 and then an M1 A1. So there's 3 marks for basically evaluating the mass. Then going on from that, then, for setting up this integral, the pi y squared x dx1, there was an M1 mark and a couple of accuracy marks for working through that integral correctly. Firstly putting the right terms in and then working through it correctly. Right, where are we now? I'll just count here. So there was 3 for the first part, 4, 5, 6, there's 3 marks left. For putting them together then, here there was an M1 mark, and then 2 accuracy marks. I think I've got one of those accuracy marks should probably go up in the integral. But that's roughly how the 9 marks were distributed there. Okay. You can see the method marks were for the setting up the correct integrals, the form of the integrals. The accuracy marks were for doing the integration. And this one method mark here was for putting together the m times x bar equals that second integral. So I hope that was some help, and thank you for listening.